Okay, so thank you so much, Christophe Ballif, for joining us here in the EPFL pavilion. We are here to discover this new exhibition called What is Art? So it's about new technologies, innovative solar technologies. And as the director of the CSEM and of the Photovoltaics laboratory of the EPFL, you've been working for many years on these innovative solar technologies. So how does it feel to finally see a part of your work exposed here in an artistic approach?
Well, it's emotionally very strong. First, just to come here to see the beauty of the place, to see the beauty of these masterpieces, independently of whether we contributed to that or not. It's just amazing when you know what a solar panel was still a few years ago and what you can do today.
Exactly.
So first, when I see here, I feel fantastic. You can do amazing things with solar, and I also can see a lot of different samples, and I also know all the work that has been behind all these pieces and developing the technology, and it's not my work. I mean, I contributed to some of the inventions, but then many people contributed, the teams of Laure at EPFL and CSM, and with Compass contributing to making all these beautiful, let's say, new ways of showing and making energy, but also of pleasing the eyes.
And we already knew, of course, solar technologies. It's not something new to integrate solar panels into new construction projects. But here, the fact is that these panels are quite unique because they are modifiable. The aesthetic dimension is really strong, and it's a key component of the product. So what was the trigger to develop and increase this specificity of the technology?
There have been several triggers. The first one is that, you've already seen regular solar modules. You have these large solar cells, they are blue. You have also some ribbons to interconnect the solar cells, so it's not particularly beautiful. And in the past, when people wanted to do something special, they would really try to colorize directly the solar cell. But you can do that, but you need to go into the manufacturing line of production of the solar cell. It's very costly. It's very difficult to really modify anything. And there have been only a very few projects done. So basically what you had a few years ago was only the possibility maybe to make something black, to put some black colors so that you don't see this copper ribbon. But the trigger was really when we started to do in the years 2007, 2008, some modification, first on one kind of module, thin film silicon, but it almost disappeared from the market. But then we realized that by putting various filters, light diffuser, dye in front of solar modules, you could actually start to hide the crystalline silicon solar cell, and you could start to create amazing visual effect. And another trigger is that normally we worked also a lot on making very high efficiency solar cell. And it's true, one day I realized, wow, we have so much current that comes from the infrared part of the spectrum, but this part, we don't see it. So we could use our solar cell more in the infrared part of the spectrum, and we could use the visible part of the spectrum to start to create stronger color effect. And that's why we came, I think, in 2014, 15, with the first really, truly white modules. And once you have white, then you can start to play doing pictures. For that, you will need to re-add something. Typically, re-add some dyes, which will reflect the color you want, but that still lets the infrared go through. So we are playing really, with white that reflects all the visible light and some kind of dyes.
Okay, interesting. And so in terms of, from a technical perspective, what kind of technological process did you have to create and to invent in order to build and produce this new kind of integrated solar panels?
Well, actually, first, I cannot say all secrets that are behind that, because some are patented, some are still under industrialization. And actually, for this exhibition, there are at least 3 or 4 different technologies that are used. But basically, what you really have is this playing with light, and playing with light means, scattering lights so that you don't see the features inside the module, so you need to distribute the light. It is about reflecting some colors specifically so that they come out, and it is still trying to keep a good efficiency of your module, because in the end you still want to produce energy.
Yeah.
So you need to play with all these components, and then all technology will have their specific properties, such as the beautiful Kaleo picture here.
Yeah.
I mean, this is really the best you can do in terms of photographic contrast. But of course you will have maybe less efficiency, but this is so beautiful.
Yeah.
Who cares? And on some of the other examples, depending on the degree of color that you get, of course, if you have a white, by definition, if it is a strong white, you will lose more current in your solar module than if you have a light white or a dark gray. So the closer you are to black, in principle, the more you can come close to the original power of the module.
Okay.
But it's also not the point to try to make, let's say, the absolute best efficiency, because here what we're doing is our masterpieces or building elements that can go to places where you would have zero energy before. And suddenly you can start to make 100 kilowatt hour per square meter, 200 kilowatt hour per square meter. So you start to produce well enough energy with a huge potential. But we're going to come to the building maybe back later.
Okay, great. And just a few words about the economic perspective, because of course, as we know, China has been dominating the standard solar panel production for many years now, and it's certainly not going to change in the near future. But here, in this specific field of modifiable solar panels and efficient solar panels, do you see it as a new economic opportunity for European industries?
Well, certainly there will be a market that will be a growing market, with especially, I would say, the colored modules that can go into building facades or on protecting roofs. Why is it? Well, simply there is a huge amount of surfaces that are available that see the sun every day. Just if you consider Switzerland, you could produce on Swiss facade almost 15% or even 25% of the electricity we use today. So 25% you could produce by putting such elements on facades. So there is a huge energy production potential. So this is the first thing that people will start to put more and more on the facade. Second, people want to also be more independent with the energy.
Exactly.
And if you have a building, if you have especially a high building, you cannot put so much photovoltaic on your roof. So you will be somehow forced. And also some regulation are going to trigger people to think of the facade no more as an inactive element, but also as an energy producing surface. So if you see all that, you see that there is a market, and this market could be a market that grows to several hundred megawatt and then gigawatt per year.
Okay.
1 gigawatt is the peak power of a nuclear power plant. So this is an interesting market. And why can European company play a role here? It is because you are no more in the pure mass production. You need to have some production volume, but you are into products where you need the proximity. You need the proximity with the company that makes the product. You need a feedback to the architect. You need a trusting relationship. And it's going to be very hard to just order something in China, get it here, and that it works at once. So it will... So for creating a lot of companies, and we have actually already in Europe a quite important tissue of companies that manufacture, solution, special modules for the buildings. And this company will all evolve to offer more and more diversity. And this, of course, should please the architect, which are the next big category of people who really need to play their role in making this energy transition.
So if I follow you, in this field, maybe the economic model will move from something global to something more local.
Yes, and this is a clear trend. And by the way, you even see that in the standard manufacturing of solar technology, there are, again, announcement of companies starting to launch production of solar cells in Europe.
Okay.
And our teams in Neucha have contributed to the fact that you have production lines in Italy now. You have new production line in Germany with technology we developed in Neucha also. You have production lines in Russia for solar cells. And for the solar module, the investment to make a production line is much lower. And you have in Switzerland already quite a few companies manufacturing modules. So they sometimes purchase the cells in Asia, but they manufacture the module in Switzerland. And you have also in Europe maybe 20 or 30 companies really addressing this market. So it's a local product. You create jobs. You create jobs in the installation. And the core component, even if it would come from Asia, it comes at such a low price and such a high performance that you're not losing too much of the value of the final product.
Interesting. And what about the energy transition? What role should these technologies play in the energy transition, and what are their potential? As you mentioned it in Switzerland, but maybe from a European perspective as well.
Well, so here we need to speak about the global role of solar electricity. And not only the building. The building will be a part, and it's clear for cities and for villages and for protected areas, we need a lot of special solution. But globally, already now the big solar parks are really producing the cheapest electricity you can think of worldwide, less than 2 cents per kilowatt hour in the sunny part. Even in Germany, which is not especially sunny, you can make electricity below the wholesale electricity price, 4 cents. It means photovoltaic is de facto becoming the cheapest electricity source with a very low CO2 impact. Then, of course, you need to manage it, but this you can do it with all kinds of technique, including with storage or with activating your heating of water or heat pump at the right time. So when you make scenario, you see that actually the cheapest way to make the energy transition is to deploy massively this form of energy, and this form of energy are solar, wind, and of course hydro, because we already have a lot of hydro in Switzerland and many other European countries. Develop biomass in a suitable way, and we really work on scenarios, and we also teach what are the latest results of all these studies. And you can see in the case of Switzerland, there is even the Swiss Office for Energy saying now we need to put at least 35 gigawatt of photovoltaics on the Swiss roofs and facade. For Europe, for making a complete energy transition, we would need to put 7,700 gigawatt of photovoltaics. And part of this electricity will be used, for instance, also for making hydrogen. Because then it will be so cheap that you can really make hydrogen at a low cost. And hydrogen will also be used for industrial processes, for long-distance transportation, or even maybe to power some gas turbine, but with a fully clean hydrogen. So, and there is no cheaper cost to do that in the long term than with solar. So that's why I think solar and with wind will become the electricity source and the energy source #1 of the world within the next 30 years. Providing you still need support, you still need regulation, because there are too many lobby and too many strong forces coming from fossil fuel industry.
Sure, and we'll come back later to that point, which is an essential part of the problem. I also wanted to ask you, so here we have a mature technology. It's available, it's really efficient, and the cost production is really competitive. What do we miss from a technical perspective, or maybe from an architectural perspective, in order to have a large-scale deployment of the technology? And maybe we could imagine that every new building in Switzerland could be built with this kind of integrated solar panel. So what is missing to really go on a larger scale?
Well, not so much is missing. So we start to see projects with several hundred square meters of colored photovoltaics. And what is maybe still missing now is that many more people are aware of that. What is missing is the will of architects at some point to really think, but when I do a building, it is my responsibility for the world to produce as much energy as I can in my building. So for me, if I would be the boss of Switzerland, I mean, houses would be solar. You would not notice it, but they would be solar. And why do you need that? Because the more you're going to do, the more you're going to help the people who try to make this special product also to get the price down, to improve the technology. You will have everybody getting used also to how do I install my modules, which mounting system do I use for my facade. So we need to create a market first. We need to create acceptance. And this here, I think it's fantastic because nobody can come here and think, well, solar is something that's not nice or that is inaesthetic. They start to see the potential. So it's a goal to really touch people. So we're going to see what happens. I hope many architects see that. And also many architects realize that they need to use a lot of these technologies or others. They can also use black modules. But importantly, they'll have to do something. And not only a few square meters or outrageously expensive project
Yeah.
that only one can do. You need project that can be done 10 times, 100 times, 1,000 times. And then you will have this virtuous circle
Yeah.
where price also go down, it's become even more attractive. And for many buildings where you are substituting quite expensive material with photovoltaic, in the end, you will have hardly any additional cost.
Yeah.
But in addition, you're going to create this clean electricity.
Okay, I see. And so what about politics? Because what can we expect from our political authorities in order to support the large-scale deployment of this technology? Is politics a powerful lever in order to support the adoption of this new technology?
Well, in general, politics is essential in creating the right frame condition so that all renewables can develop. And if you see all the improvements that have been made to solar technology globally, they've been first due to the fact that Germany has introduced politically the Erneuerbare Energiegesetz, so a law that would really give a good feed-in tariff for solar plants. So policies are determining in the way of either supporting renewable energy or in terms of punishing the energy sources that bring with them a lot of problems. And we know global warming is a huge problem. It's still fully underestimated, and we need to act. So the role of policy is to, let's say, put taxes, find ways to, or even to prohibit. It's maybe sometimes easier than just putting taxes. Prohibit what is polluting, creating a lot of CO2, and find a way to encourage, give, for instance, a grid access to electricity at a fair price. And if you do that, then things develop, and they can develop very, very fast. And maybe it's quite interesting that if you put the right frame condition, then you can let the competition express itself.
Okay.
And then people will be creative. And at the point where, like, if a solar facade would be something that is a must, or if a solar roof, not 10% of the roof, but 100% of the roof, would be something that becomes almost compulsory, I can tell you that all people involved in the building industry would very quickly learn the process on how to make something like this. And then you would have the people who are ready to do something maybe a little better, a little nicer, a little more attractive, and they will start to use this kind of technologies. And here you always have these people. So we see that there are really a lot of citizens that, and we made really study on that are ready to pay 20, 30, or 50% more to have something nice. So this market will automatically also grow.
Okay. Yeah, interesting. And maybe one last question about the product itself. So we mentioned the aesthetic dimension of this new kind of integrated solar panels, and also the efficiency. I wanted to know, for you as a scientist and a technological researcher, how did these two imperatives impact your work, having a technology that is aesthetic and efficient at the same time? How did it impact your work?
Well, I would say I'll take the question a little differently.
Yeah.
The first time when I came with in the major photovoltaic conference in Washington, D.C., Trump just been elected.
Okay.
And I arrived with a photovoltaic image, a small version of that. People were first so surprised. So people had not thought about that you could do something like that. So it was really, really a highlight for people. Wow, we can do such things.
Okay.
And then you have two kind of reactions. You have the engineers who said, well, but you cannot sacrifice efficiency of a photovoltaic module by hiding it. So this is really the pure engineering approach. You need to make the maximum. And then you had all these other people who had been working with art or with architects and who know the value of doing something nice. And these people were fully enthusiastic.
Okay.
And actually, this is what we've been trying to do in Neuchâtel for many years, was exactly to try to bridge, let's say, between maybe the aesthetic and the art and with the engineering. And in the middle of that, you have these beautiful products, which are, of course, always a compromise between efficiency and visual look.
Yeah.
But as I said, now today, the solar cell is not only so cheap, it is also much less energy demanding to manufacture than before. So even if you lose 20 or 30% of your original power, you're not doing, let's say, something that is bad for the environment. You're still doing something positive.
Okay, great. Great. Thank you so much for all these explanations.
You're welcome.
And yeah, that's a beautiful exhibition to discover for the next months here in the EPFL pavilion. So thank you so much.
Yeah. One day you'll see these kind of modules, I'm sure, on so many buildings, so many facades, the terracotta on so many roofs. There is so many things we still have in the lab and in the pipeline.
Yeah, then really you'll be happy. You'll have your achievements as a technological professional and scientific worker.
Well, I mean, we do that because we think that it's important for the planet, and we think that technology is not all the solution, but technology is part of the solution. So ideally, people should use less, should consume less things that are futile, should not use Bitcoin, which are so energy demanding.
That's right.
But at least, I mean, you can now, you have ways to power the world with much less impact on the environment. This is very good, and it's moving fast.
That's great. Yeah, that's really interesting. Thank you so much.